Imagine stepping into a tunnel that doesn't just go through the Earth, but through the fabric of space and time itself. You can walk in, take a few steps, and then suddenly you're on the other side of the galaxy, or maybe in an entirely different universe. This mind-bending idea is at the heart of wormholes, one of the most intriguing mysteries of the universe. Wormholes, sometimes called Einstein-Rosen bridges, are hypothetical tunnels through space-time that could connect distant points as a cosmic shortcut. They captivate our imagination in science fiction, but today we'll explore what real science says about them, and what they might mean for the future of cosmic travel. So what exactly is a wormhole? In simple terms, it's a bridge between 2 points in space-time. If space and time are seen as a fabric, a wormhole is like a tunnel that punches through that fabric to join two far-apart locations. The concept first emerged from Einstein's theory of general relativity. In 1935, Albert Einstein and Einstein-Rosen realized that Einstein's equations allowed strange bridges in space-time, essentially a shortcut that connects 2 points in the universe. Another early contributor was Austrian physicist Ludwig Flamm, who in 1916, while reviewing solutions to Einstein's equations, imagined a sort of mirror image of a black hole, later termed a white hole, and suggested that it could connect to the black hole, forming a tunnel. So a wormhole might have 2 ends or mouths, and a connecting tunnel often called the throat. So what would it look like? Interestingly, we theorized not like a typical hole or door. Scientists say that the mouth of a wormhole would likely be spherical. Think of it like an orb where if you look straight in, you don't see our side of space, you see whatever is on the other end of the tunnel. Light from the far end would be coming through, possibly making the interior view appear highly distorted. As you travel through, you'd see warped images of the region you came from and the region you were traveling to. A very strange sightseeing tour indeed. So have we found any wormholes out there in the universe yet? Short answer is no, we have not. Black holes, which are kind of like one side of a wormhole in some theories, have strong observational evidence, but wormholes remain purely hypothetical at this point. No telescope has ever spotted a wormhole out in space, and there's no experimental evidence of one being created in a lab either. There are mathematical solutions to the equations of general relativity, which means they could exist according to our best theory of gravity, but whether nature actually makes them is another story. Nobody thinks we're going to find a wormhole anytime soon either. One reason that we may not have found one yet is that they could be extremely small. Some physicists think that if wormholes formed naturally, they might have popped into existence right after the Big Bang, so-called primordial wormholes. These might have been as tiny as 10 to the negative 33 centimeters across. That's trillions of times smaller than an atom. Over billions of years of cosmic expansion, some of these mini wormholes may have been stretched to larger sizes, but they could still be very hard to detect. Another speculation is that wormholes might be popping in and out of existence at the very smallest scales. At the Planck scale, space-time is thought to be somewhat of a quantum foam, and tiny wormhole tiles could be forming and vanishing within that foam all the time. If so, they're far too small and short-lived for us to observe, but we have no idea how one could ever be enlarged to human scales. In any case, even if nature makes a wormhole, we suspect it would collapse almost as soon as it formed. An Einstein-Rosen wormhole, the simple kind connecting a black hole and a white hole, would pinch off so quickly that not even a beam of light could get through from one end to the other. In other words, even if a wormhole somehow appeared, it might disappear before we ever had a chance to notice. So the wormholes you see in movies, are those just science fiction? You know, the kind that you could fly a spaceship through. These would meet special conditions to actually work. Physicists distinguish between non-traversable wormholes, like the Einstein-Rosen bridge, and traversable wormholes, which could theoretically carry matter and light without collapsing. In order to get a traversable wormhole, scientists believe the tunnel must be held open against the immense gravity trying to pinch it shut. So how do you hold a tunnel in space-time open? The answer would be with something that has negative gravity, essentially exotic matter. Exotic matter is the term for matter with negative energy or negative mass, aptly named indeed. Under general relativity, negative mass would gravitationally repel instead of attract. If you could line the walls of a wormhole with a shell of negative energy, it would push outward and keep the throat of the wormhole from collapsing. This idea was first seriously studied in the 1980s by physicists like Kip Thorne and his colleagues, who wanted to see if the laws of physics permit wormhole travel. They found that relativity allows traversable wormholes in principle, but only if this weird negative energy stuff exists to stabilize them. The catch is, we don't know if exotic matter of the required kind can exist in large amounts. We do see tiny effects of negative energy in quantum physics, but nobody has ever observed a macroscopic negative mass object that we could use. Even optimistic scientists acknowledge that traversable wormholes might be impossible in practice. Kip Thorne himself has said that there are very strong indications a human-sized wormhole that someone could travel through may be forbidden by the laws of physics, which is a huge downer for our interstellar vacation dreams. But remember, forbidden by known physics could just mean that we haven't figured out a way yet. It's not outright proof that they can't exist, it's just that we see no easy way for nature to make a stable, travel-friendly wormhole without ingredients that may not be real. So, suppose just for fun that traversable wormholes do exist somewhere out there, or maybe some advanced civilization has managed to engineer one. Possibilities of this would be astounding. First, they would allow faster-than-light travel without actually breaking the cosmic speed limit. How? Because if the wormhole connects two distant points in space, you could traverse that distance faster than a beam of light would take going through normal space. It's like a shortcut through the fourth dimension. From the outside perspective, it looks like you jumped insanely fast, but inside the wormhole, you've just walked through and taken a very clever shortcut. In theory, you could step into a wormhole near Earth and come out near a planet orbiting another star many light years away, all in a matter of minutes or hours. Wormholes could also allow inter-universal travel, connecting not just two places in this universe, but two different universes altogether. Some solutions to Einstein's equations hint that a wormhole could link separate universes and a kind of bridge. If that were true, a wormhole wouldn't just bend space. It could bend reality itself, letting you step into an entirely different cosmic realm. This is a very speculative idea, but it's something theoretical physicists has considered as a possible way to avoid paradoxes. For example, if a wormhole allows time travel, maybe it actually sunts you into a parallel universe to prevent timeline conflicts. Speaking of time travel, wormholes have become quite famous for their connection to time machines. Here's how that would work. Relativity tells us that a clock moving at a high speed or sitting in a strong gravitational field will take slower compared to one at rest. It's called time dilation. So imagine you have a traversable wormhole, and you take one mouth of it on a high-speed journey. Say, fly it near the speed of light or park it next to a black hole for a while, and then bring it back. Do the time dilation, that moving mouth has aged less than the stationary mouth. Maybe only a few years passed for the traveling end, while decades passed for the stay-at-home end. Now, the two ends are no longer synchronized in time. If you enter the younger mouth, the one that experienced less time, and exit through the older mouth, you'd emerge in the past. Essentially, you have traveled back in time. You could also go the opposite direction through the wormhole to arrive in the future, relative to where you started. So in theory, a single wormhole could be used as a two-way time portal to different eras. So could we ever find or make a wormhole? Scientists haven't given up on the idea just yet. One approach is to search for the gravitational effects a wormhole might have on its surroundings. A wormhole with mass, especially if it had an exotic negative mass, would bend light and gravity in very telltale ways. In fact, researchers have proposed that a negative mass wormhole might be identified by how its gravity lensing differs from that of a normal black hole. A recent 2023 study calculated that wormholes, if they exist, could magnify the light of background stars by a factor of 100,000, far more than any known black hole's gravitational lens can. Even more intriguingly, the pattern of light might have a unique signature. The study suggests that wormholes would produce two distinct brightness peaks in a light curve, whereas a black hole would produce only a single peak. So, in essence, if we see a gravitational lens event that's too extreme, it has this double-peaked fingerprint, we might just be looking at a wormhole. So far, nothing like that has been observed in astronomical data, but new telescopes and sky surveys like monitoring stars for microlensing events could reveal anomalies like this in the future. So, in conclusion, wormholes remain an exciting enigma at the frontier of physics. They're permitted by Einstein's equations, but they have no evidence in reality so far. They tantalize us with possibilities of cosmic shortcuts and even time machines, but they come with daunting requirements and paradoxes. As much as we love to find a ready-made subway tunnel through the galaxy, the universe isn't giving up its secrets that easily. Still, studying wormholes pushes science to its limits, illuminating how space and time work on extreme scales. And who knows, perhaps in some far future or some hidden corner of the cosmos, naturally occurring wormhole might be found, just waiting to be explored. Until then, wormholes straddle the line between science fact and science fiction, a testament to the boundless curiosity we have about our universe's mysteries. Thank you very much for watching. If you enjoyed this video, be sure to hit the like button and subscribe for more videos like this one every week from Stellar Quest. We look forward to seeing you around.